and the reflectance is very low. It is within 0 to 10%, and peak we get around green band. So the point number second, with respect to the water reflectance, the highest transmission and least absorption in blue and green region. And the presence of material in suspension increases the reflectance. That we discussed with respect to these two images, where in the first case water is clear, while in the second case, due to the suspended particles, that is due to the increase in turbidity, leads to increase in reflectance. That is point number 3. Okay. Now, chlorophyll content decreases the reflectance at blue, but increases at green band, and this is used for the algae study. Now, there are some other regions due to which water absorbs, this water reflectance changes, and they are this: the pH value, salt concentration cannot be directly absorbed, but as no change in reflectance uh, occurs due to these constituents. So till now, we have analyzed the spectral signature of vegetation, water, and soil on the basis of internal composition of uh, these objects. Now, there are other factors which affect the reflectance. The first, that is a temporal change. From the same material, same object, the change in reflectance over the time. Like when we consider the vegetation, the properties of leaves changes with respect to both period of the tree or of the plant. When we consider, even with the change in season, the reflecting behavior of leaves will change. Okay? This is why the reason is that the internal composition changes with respect to time. And there are the special effects, like at any moment, even same type of features may show different reflectance due to their different spatial location. And like changed soil type, change in climate, change in irrigation practices, due to which there could be the change in water content. So if there will be the change in water content, I think there were some queries in the middle when I was discussing slide 52. Yeah, please continue.
सर जब हमने लैब किया था पहले वाला, तो सर उसमें हमने जब उसका हिस्टोग्राम देखा सर, तो उसमें डीएन वैल्यू का दिया था 000 समथिंग। तो क्या सर हम पूरा वो पूरा वाटर को रिप्रेजेंट कर रहा है?
Let me know. Just briefly, I will discuss that part over here. I select NIR band, design a sensor. Okay. So this is the satellite onboard sensor, and it is used for the imaging. Okay, so I was discussing about when we select a spectral band in a sensor in an IR band. Now it is used for sensing the ground surface that is comprised of water, soil, vegetation, etc. Fine. When we analyze the water bodies, let's say there is a water channel over here. What it does first, it automatically divide Okay, sorry for the interruption. There is some issue at my end, and actually it is getting disconnected. I hope you can see the slide.
Yes,
Yes,
sir.
sir.
Okay. So there is a water channel. I'm just discussing with you the process, how the imaging takes place. So this satellite onboard sensor satellite is continuously revolving around the Earth's surface in sun-synchronous orbit, as I discussed before. It means the sensor looks towards the area Okay, the sensor looks towards the area where there is a midday. Okay, so maximum illumination is available there. What it does, it automatically divide entire area into grid. It's a virtual kind of analysis, I can say. It's only for the understanding. So virtual grids, it means the entire area is the sensor looks entire area into its gridded form. Okay, so we have grids. Okay, so I told that the sensor that is designed in NIR band, this sensor looks towards Earth's surface, okay, and one by one it senses the grid. Okay, so we select a grid from water body. One grid, this one is selected from water body. What happens if we see the spectral signature of water, that is reflectance versus wavelength curve? So there we have a reflectance from water and it is very low. It is within 0 to 10%. Where in NIR band, we don't have the reflectance. What does this mean? It means the incident energy uh, in, a, in a complete spectrum, the reflected component will be there only in visible spectrum, while for all the wavelength more than 0.7 micrometer,